The sulfite ion is SO3, -2. So again, we cross them out. We get Na2SO3. It's also possible to combine polyatomic ions with each other. The ammonium ion is NH4 positive. The phosphate ion is PO4 -3. Once again, we can crisscross. Here's where the need for those parentheses will come in. I need 3 NH4s and the 1 PO4. So the correct formula there for ammonium phosphate, NH4 taken 3 times, PO4. The last one, I've got the lithium ion. That's Li+. I've got the nitrate ion, NO3-. Here's a case where the positive charge and the negative charge are equal to each other. They're 1 and 1. I don't need to crisscross. If I did, they'd come out 1 to 1 anyway. But if the charges are the same, we don't need to crisscross. We just rewrite it, LiNO3. They exist as a 1 to 1. We can write them as a 1 to 1. All right. Any questions here? Biggest trick to this is you have to know what the ions are. Kind of hard to write the formulas for a compound if you don't know the formula of the ions that make up the compound. Okay, so now we get into naming, the actual nomenclature of ionic compounds. And we, again, come to a recognition. If we recognize that there is a metal and a nonmetal in the compound, or we recognize the presence of one of those polyatomic ions, then we know we're dealing with an ionic compound. And if we're dealing with an ionic compound, it is going to follow this very structured naming system that I'm about to show you. So again, recognition, ordinarily, if you can find a metal in it, there's a very good chance that it's ionic. As you get better at recognizing polyatomic ions, that'll be another very easy way to recognize that a compound is ionic. Here's the process. When we name ionic compounds, we do it in a 2-stage system. The first stage is the name of the cation. The cation is the ion that is positively charged. That's usually the metal ion. The second name is the name of the anion, the negatively charged ion. And that's either going to be a nonmetallic ion with the IDE at the end, or it's going to be one of our common polyatomic ions. So in naming ionic compounds, it always follows that formula. Positive, then negative. positive, then negative. Cation, then anion. Cation, then anion. So it's about the recognition of those things. So before we get into practicing the naming of the compounds, we're going to go back and look at how do we name the pieces. And once we know how to name the pieces, then we can bring them together to name the compound. So for cations, ordinarily, cations are metallic elements. And so their name would just be the name of the element based on its charge. Sodium ion, barium ion, beryllium ion, potassium ion. When we get into those transition metals in the middle, we have to be a little bit more specific with them because some of them have multiple charges. So we have to designate their charge with a Roman numeral. Iron 3 ion, iron 2 ion, nickel 1 ion, nickel 3 ion. The only one that doesn't fall into this pattern is the ammonium ion. Ammonium ion, NH4 plus 1 charge, is the only polyatomic ion that meets that description. All of your polyatomic ions have a negative charge, with the exception of ammonium. Ammonium does carry a positive 1 charge. It's the only one that does so. Now, one important thing, this comes up in your proficiency. I want to highlight it and make sure that you're aware of it here as well. When we are naming ions, you'll notice that we always put the word ion at the end of the name. Why do we do that? Distinction. We need to be able to distinguish ions from their elements that have the same name. Ions from their elements that have similar names. Ions from compounds that have similar names. So the word ion there, it seems like kind of a nuisance, seems like extra information that we don't need to put in there because it's assumed, but it helps us with the distinction. And so when you're naming ions on that proficiency, you're going to have to make sure that you designate them as ions, which means you're going to have to put the word ion at the end of them. As I mentioned before, with transition metals are capable of having a variety of charges. When a transition metal has multiple charges, we put the charge of that transition metal in the name as a Roman numeral. Allie?
So on the efficiency line, if it's transition metal, we have to put the charge like where we want.
If it's a transition metal and it has multiple charges, yes, you'll have to do that.
Right.
Now,
is there any that will need it if they're not?
So the only time we use the Roman numerals is if that metal carries multiple charges. The ones that don't, you can actually draw a line. So let's see if I have a periodic table at the ready here. I may not. Okay. The ones that don't basically form a tiny pyramid inside the transition metal, starting with zinc. So zinc and silver and platinum, well, zinc and silver, cadmium and indium, they form this little pyramid, and those ones don't have a variable charge. Zinc and cadmium are always positive 2. Silver and indium, silver is positive 1. Indium is positive 3. Those are the ones that do not have variation. The other ones have some variety and you would need to designate them. So again, you can kind of draw just a tiny triangle right around with zinc as its point. Those 4 elements don't vary in their charge. All of the other transitions do in some kind of way. And the designation is the Roman numeral here. +2 gives us the Roman numeral 2. +4 gives us the Roman numeral 4. And again, the naming of those is the same. This cation right here is the iron 2 ion. This one underneath it is the iron 3 ion. Underneath that is the copper 1 ion. Underneath that is the copper 2 ion. All we do is we throw those parentheses around that Roman numeral to designate the charge. And so that's a really important thing to recognize. It is the charge that is given by the Roman numeral, not the subscript in the formula. Probably one of the most common mistakes made is they see something like iron 2 chloride here, and they end up writing in Fe2Cl because they think that the Roman numeral there refers to the subscript. It doesn't. It refers to the charge. The iron is a +2 charge. The chloride is a -1 charge. The charge of the compound after you crisscross is FeCl2. All right, so we will pick up with that and talk about the naming of anions and the naming of ionic compounds in total, along with some other things coming up on Friday.